Okay, so today we are doing 3-4, and 3-4 is about the rational root theorem, and also us starting to find roots when we don't, when we can't factor them and we don't have any other clues of what they could be. So rational root theorem, and also finding some rational roots and real roots. Next time, which one's the next time I see y'all? Y'all are B-Day, so I won't see you till Wednesday. We'll be doing imaginary numbers and more, the things with the eyes in it. That's what happens on, we'll do 3-5 and 3-6 together on Wednesday. So our rational root theorem, and you'll probably remember this from last year, we're going to use this when we're finding our possible rational roots. So these are to find our possible rational roots. So if we are looking for those, these are just going to be like, I don't know anything about the polynomial. I have no idea what any of the roots or zeros could be. This is going to give me a clue, so you have somewhere to start. So our possible rational roots, they always come in this form, okay? They come in the form plus or minus P over Q, where P is a factor of the constant and Q is a factor of the leading coefficient. So remember, our constants were our numbers at the end that don't have variables with them, and our leading coefficients are the coefficients are the numbers in front of the x for your highest degree power. So we'll look at one and see how it goes. So let's say that I have the following polynomial. F of x equals 3x to the 4th plus 2x squared minus 6. So your possibilities for your rational roots are going to be combinations of the factors of the constant over the factors of the leading coefficient. So which of these numbers is the constant? The constant is the 6, right? So this is how we're going to get our p-values. We're going to do factors of that.
We are going to send another group to A tower or D tower, whichever is closest to your classroom. Last night starting with a G, H, or an I. Thank you.
And what is the leading coefficient? 3. So this is how we're going to get our Q's. Okay. So I like to first write it out just in one fraction like this. What are all the factors of 6? What numbers go into 6? 1, 3, 2, and 6, right? 1, 2, 3, and 6. Those are possibilities for numbers on the top. What are factors of 3? 1 and 3. So those are possibilities for numbers on the bottom. So all the combinations of these 4 numbers on top and these 2 numbers on bottom are going to be our possible rational roots. So I can write them out. If you don't want to write them all out, if you can see it from there, that's fine. So I could have plus or minus 1 over 1, plus or minus 1 over 3, plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 3 over 1, plus or minus 3 over 3, plus or minus 6 over 1, plus or minus 6 over 3. Some of those are duplicates because 6/3 is the same thing as 2, but I just wrote out all of the combinations. Okay. So one thing for us to notice is that if they're fractions, What is the denominator for all of these that are fractions? The denominator is 3, okay? So these are going by thirds, so they could be increasing by thirds if you're thinking of that. The 3 comes from our leading coefficient. That's going to be important when we make our table. Okay? So you could only have things that are whole numbers or things that are for thirds, just thinking about that. But if somebody told you, I think one of my possible rational roots is 5, you would say, would you say that's okay or that's a no? Could 5 be a root? No, 5 doesn't go into 6. That can't be a root. If somebody said, I think it's 1/2, could 1/2 be a root? Do I have a 2 on the bottom of any of these? No, 1/2 couldn't be a root. Okay.
What about the, never mind.
The ones you simplify? It wouldn't simplify to 1/2. One of them simplifies to 2, though, just a regular 2. So part of your assignment today, you'll have to pick out the list of them. Make sure you pick the one with the plus and minuses. I always start like this just to make sure I have it. But factors of the last number over factors of the first number. And what that does is that limits down our possibilities for our roots from an infinite number of possibilities to just, how many is this? 8 times 2. Some of them are overlapping, but a maximum of 16. Okay. So in the olden days, you would take this list and you would start trying to see if those roots or if those possibilities were actually roots using synthetic division. So used to, we would have to try them all and test them in synthetic division. And if we got 0 as the remainder, we knew it was a root. But now we're going to use the calculator just kind of for a shortcut for it. But the statement's the same, and it's important for us to know that if we're finding rational roots, like actual ones, so if we're trying to find our actual rational roots, here is an important statement for us to know that if you divide a polynomial by x minus c, and the remainder is 0, so if we divide it and we get a remainder of 0, we already know that means that x minus c is a factor, right? That's what y'all did yesterday. You checked to see if the remainder was 0, so you could tell if it's a factor or not. And if it's a factor, you know that you can use that to get one of the roots, okay? So if x minus c divides evenly and the remainder is 0, then c has to be a root. Y'all are probably like, duh, I know if it's a factor, then I can just change the sign and I know that one's a root. Okay. So what we're going to do is we are going to test. We'll just do a little test to see if one of these things is an actual root. Then we'll do some calculator work. we're going to see, is 1 a root of f of x equals x cubed plus 3x squared minus 4x minus 12? So if it's a root, we're expecting to get 0 as the remainder. Okay. What do you guys think we're going to put in our box? 1, right? Remember when you were doing synthetic division, I always made you say, what would the root be? Whatever the root is, that's what's going in your box. If you were thinking about dividing that or thinking about the factor, what would be in the parentheses for this? Wouldn't it be x minus 1? If you were thinking in factored form. So if we're dividing by x minus 1, we always revert back. We'll do 1. So if they're just asking you if something is a root, you don't do any sign switching because the actual roots, that's what we're putting in the box. Okay. So we're putting 1 in our box. We'll do 1, 3, -4, and -12. So y'all go ahead and do that real quick, and then you can tell me if it is a root or not. No? I see a no. Okay, everybody else can finish too. Then we'll see. Do I see any yeses, or are we all thumbs down? All right. So drop our 1. 1 times 1 is 1. 1 plus 3 is 4. 1 times 4 is 4. -4 plus 4 is 0. 0 times 1 is 0, and that makes -12. So that is a no-go. That's our remainder. Since it's not 0, 1 is not a root. So 1 is not a root, and x minus 1 is not a factor. Okay. Shelby, are you okay? Oh, you found a calculator?
I found my calculator from like last year, and I haven't used it since like March, and it still turns on.
Well, that's good. Yeah, I didn't charge them all. We just left, I left them here, and some of them still are good. I had to charge the rest of them of my classroom set. Okay. All right. So I'm going to show you guys a neat little trick, because if you were trying to figure out what the possible roots are, we've got factors of 12 over factors of 1. And the factors of 12 are 1, 2, 3, 4, 6, 12. You would have the positive and negatives of those all over 1, which would just keep the whole numbers. And I don't want to have to test 1 didn't work, so now let me try -1. Now let me try 2. Now let me try -2. Now let me try 3 and try -3, because that would take a whole long time. Yeah? Do y'all agree with that? So what I'm going to have us do is have the calculator at least find the first root for us. Sometimes it will find all of them for us. Sometimes it just finds the first one, and then we have to use synthetic division after that. Okay. But remember, one thing to recall from last year, how many roots are there going to be of this polynomial? Do you remember? There will be 3. The degree is the number of roots there are. Okay. That is also a part of your homework this time. You're just given a polynomial, and they want you to say how many roots there are. It's just your degree. So I gave you those as just some easy questions on there. So for us, what we're going to do is we're going to get our calculators out. So go ahead and have yours out, whether it's on the computer or in your hand or on your phone. And we're going to see if we can figure out what our roots are. We're looking for 3 of them. So I've got my little, wish I could make it bigger. Oh, I can. Good. Can y'all see that? Is that okay to see? Okay. So we are going to type our equation into y equals. So the equation that we just wrote down, the x cubed plus 3x squared. So x cubed plus 3x squared minus 4x minus 12. Got to fix something real quick, and then I'll show you. All right, so we typed this in. When we are looking for our roots, we are looking for x-intercepts, where it crosses the x-axis. What is your y value when you cross the x-axis? When you're on the x-axis, what is the y value? What is your y value when you're on the x-axis? It's 0, right? So anywhere across the x-axis, the y value is 0 because you haven't gone up or you haven't gone down, okay? So what we can do, we can either look at the picture graph, but it might not be exact, or we can look at the table. I like to look at the table. And anywhere that y equals 0 in our table, those are going to be our roots or our zeros. Because if y is 0, you know it's on the x-axis, and that would be an x-intercept. So once you've typed that in, your table is right above the word graph. So hit second table or second graph. And you're going to look for the times when y equals 0. So you can scroll up and scroll down. I found one at 2, -2, and -3. Lower. Dang it. There's some way I can make the screen really big, and I just can't figure it out. Nope. 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 Don't change. X. Don't change. Change. Sure. Did I mess it all up? Deleted it. Now the screen's a little bit bigger. Looks like okay. So second table, it was 0, y was 0 at -3, -2, and 2. How many roots were we looking for? 3. How many did we find? 3. We're done. So -3, 2, and 3. So that's what we did in the calculator. We can write these steps down so you can have them. So in your calculator, you're going to put the equation in y equals. Then you're going to look at the table. And you're going to see when y equals 0. Okay. So for this particular example that we just had, I'm going to rewrite the equation. You guys can draw an arrow if you want to. So we had f of x equals x cubed plus 3x squared minus 4x minus 12. Our roots from our calculator were 3, -2, and 3. Okay. Sometimes you're going to be asked to write this in factored form. We didn't do any factoring ourselves. We just found what our roots were. But if we know what our roots are, it's really easy for us to write this into factors. We've got 3 zeros. So how many sets of parentheses would we need?
Does that say f of x?
Yeah. It really looks like f of scribble, but you know. So we're going to write it into 3 factors. This is like they give us our zeros and we write it. So in factored form, it's going to be x minus 3, right? X plus 2 and x plus 3. Oh, I wrote a 3 down. It was a positive 2. Nobody told me. This was a positive 2. 2, negative 2, and negative 3. So that should be a 2. So just a recap for that, we put it into y equals, hit the table, and found when y equals 0. And we found all 3 of our answers, so we wrote them down, and then we can put them in parenthesis form. Okay. Sometimes we have options for our roots that are fractions. So you remember on that first one we did, we had all those 1/3. Like it was 1/3 and 2/3. Would we pick up the thirds in a regular table? So if you're in a regular table, I went to here, am I going to pick up the thirds for x values? Or is it just going by ones? It's just going by ones. So if you have a leading coefficient that is not 1 and you want to use this method, we need to change the table so that it goes by increments of whatever your fraction is. Okay, so we're going to write that down. It's really easy to change. So if your leading coefficient is not 1, so if you've got like 2x in the front or a 3x in the front, you need to change your table set. And table set is above window, so that is second. Erase.
That says whole set. What does that say?
TBLSET. It's the abbreviation for table. It's right above window. It's just hard for you to see that word right there. And you hit second window to get it. All right. And this is what you're going to change it to. The table start needs to equal 0. And the delta table, delta just means the change or how much your x values are increasing each time, needs to be 1 over the leading coefficient because that's going to make it increase in those fractional values. So we're going to go ahead and try one that's going to have a fraction for an answer. So we're going to have to change our table set. And then I'll show you what happens if we don't have all 3 of the answers that we need or 4 of the answers, whatever it is, what you do in that case. Okay. So if it's not 1, we have to go to the table set. I'm going to go second table set. This is going to pop up. My table start, I make it 0. My change in table, I make it 1 over whatever the leading coefficient is. Okay, so let's look at one of those. Make this bigger. Right, so we have this one. How many roots are we looking for? 4 roots. So in my box, I might want to say that I need 4 roots. I could put x equals, x equals, x equals, x equals, if you just want to keep up with them that way. Roots should be plural. There we go. Okay. I'm going to check in the calculator to see what's going on. But I do want to know that I've got factors of 4 over factors of 2. What's the highest number that I could look for a rational root? What's the biggest one it could be is 4. And the lowest would be -4. So when you're doing fractions of that and 4's on the top, that would be the biggest and the smallest. So if you've exhausted that in your table, you don't have to keep searching forever when we're looking at that. Okay. Is the leading coefficient 1? No, our leading coefficient is 2, which tells us that we could have some fractions because 2 can be in the denominator, right? So we're going to change our table set so that it picks up on the halves. That's why we change our table set. So let's go ahead. We're going to put this into our calculator. So everybody type it into y equals 2x to the 4th minus, this takes forever on here, 7x to the 3rd plus delete plus 3x squared plus 8x minus 4. Okay, do we all have it typed into y equals? Hopefully it didn't take you as long as me having to hunt and peck. So now we want to change our table set. Our leading coefficient was 2, so we're going to remember that. So table set is second window. There's your window there. Second window. We want our table start to be on 0. That makes it easier, and then we know the increments are going to go the right way. And then our delta table, or how our table is changing each time, is going to be 1 divided by, and what was our leading coefficient? 2. That means our x values are going up by a half each time, and that's going to pick up those.
What button did you click on screen from?
You go second window, and that gives you your table set.
And did I make it 0?
0 for the first line and 1/2 for the second, because the leading coefficient in our problem was 2. Okay. All right, now we're going to go to our table. Oh, online for the calculator. There's an app you can use on your phone called Calculate 84. There's not an online version of this that I know of. So everybody go to your table, and you're going to look for when y equals 0. Did we find some? I found 2, 1/2, and -1. I'm going to check all the way from -4 to 4, though. Nope. Nope. Okay. So I only got 3 of them. I'll write them down. What were they? 2, 2, 1, and -1.
After you grabbed it, you just click. How did you get it?
I hit second graph, which gives you the table.
Okay, thank you.
Okay. So we have, what was it? I forgot again. 2, 1/2, and -1. Okay. So 2, 1/2, and -1. All right. Did we find all of our roots? No. This is a tip for you guys, and you'll be able to see why after we do our next problem. We're missing how many roots? 1. Okay. When you do factoring or the quadratic formula or anything else, how many answers do you always get when you have a quadratic that's left over? You always get 2 answers. We always have the plus or minus in the quadratic formula or the factoring problems. We only have 1 left over. So if we do synthetic division, we're not going to get down to like a quadratic formula problem or anything like that. So what I want you to do, if you're only missing 1 root, there's a really good chance that one of these roots, either 2, 1/2, or -1, was a double root. So it showed up 2 times. So hit your actual graph button and look at them and see which one of these numbers, the 2, the 1/2, or the -1, is our double root. Think about the multiplicity and what that looks like on the graph. So if you hit graph, it'll show it to you. Mine is zoomed in a little bit. So I'm going to look across. This is -1. Is that a double root? No, because it just goes straight through. Here's 1/2. Is that a double root? No. Here's 2. Is that a double root? Yes. So
Yes.
when you're listing your roots out, we missed the second 2. So 2 was a root twice. we couldn't have found that on the table. We could just see it in the graph. Because it hit and bounced back, 2's a root again. Okay, so if you just lack one root or you're missing one root, there's most likely multiplicity. Okay, now we're going to write this in our factored form. We need 4 sets of parentheses. Actually, do you just want to do 3 sets of parentheses? Do we need 4? Can we just do 3? 3 works, okay. I'm just going to write the 2 at the end with a squared. So my first one I'll do the backwards first, x minus 2, and there were 2 of those, so it needs a squared. Got x plus 1. And how do we do the 1/2?
X minus 0.5.
We would think it'd be x minus 1/2, but we need a 2 in the very front of it. So what would it need to be if we need to have this 2 in the front? I see a 2x. Somebody told me 2x minus 1. If I solve 2x minus 1, is that going to give me 1/2 as my answer? 2x minus 1 equals 0. Add 1. Divide by 2. Do I get 1/2? Yeah. An easy way to remember this, we always switch signs, right? So 1/2, we'll have to switch it to negative. This is your numerator. This is your denominator. So if you have a fraction, top number, bottom number. So your numerator, denominator, if one of your roots is a fraction, because that gives us our 2 in the front that we wanted. Make sense for those? Yeah, so don't put like x minus 1/2, you're gonna do 2x minus 1. Or if it was 1/3, it'd be 3x minus 1. Here's our last one for today. I'm going to save us a little bit of time and I'm not going to have to type this in because I know what the root's going to be in the calculator. But if we're typing this in the calculator to figure out what our 3 roots are, do we have to change the table set?
Yes.
Yes, because the number in the front's a 4. So the table start is 0 and the leading coefficient is 4. So your change in table will be 1.
You
So
said our
let's
table would be what? I'm sorry.
1/4.
Okay. Oh, okay.
Yep. So your table start, you have to do 0. Your delta table equals 1/4. So we put this in the calculator. We pushed all the right buttons. We looked in the table. We found that the only time that we have an actual root, we're looking for 3 of them. We found x equals 1/2. Okay, I'm just going to tell you that just to save like 3 minutes of me trying to find those keys in the calculator. So x is 1/2 is the root we found in the calculator. We didn't find any more. We checked to see if it was a triple root. It wasn't. So we are going to synthetically divide and then solve the quadratic at the end. So if you don't find all of them, you're going to have to synthetically divide and solve whatever's at the end. So 1/2 is one of our roots. So we just put 1/2 in the box. We don't do any kind of sign switching if we actually know the actual root. Roots go in the box. Oopsie. Do I need a placeholder? Yes, I do. So 4, -6, 0, and 1. Drop that 4. 4 times a half is 2. Add them together for -4. -4 times a half is -2. Add them together for -2. Multiply, you get -1. And 0 is our remainder. Okay. What's going to be nice about these is we don't even have to try to factor them, because if we could have factored it, we would have found it in the calculator. The calculator is going to give us all the answers that are factorable. So for us, we're most likely going to have to use the quadratic equation or solve using square roots if we didn't have a middle term. So let's go ahead and write our x and our x squared. So we're going to solve 4x squared minus 4x minus 2 is equal to 0. I don't know if y'all know this, but if you have something equal to 0 and you notice that everything has got the same factor in all the terms, you can divide every single number by it because it's not going to affect the other side. Because 0 divided by anything just stays 0. As long as it's not a variable. So what do 4, 4, and 2 all have in them?
2.
They all have 2. Oh, and the purple box is 1/2. We found 1/2 in the calculator. We found.
To do an alcohol right now for anyone that has not had their yearbook picture made. You may go to either A tower or D tower, whichever is closest to your classroom right now. And I will do 2 more alcohols and then we will finish up this afternoon. Thank you.
If you need to go, you can watch me finish this one problem, or you can go ahead and go. I know some of y'all needed to go before 2 o'clock to get your picture taken. So if you're going to get your picture taken, go ahead and go. Make sure you watch this last example, though, if you are missing that, okay? All right, so we're going to divide everything by 2. We got 2x squared minus 2x minus 1 equals 0. And we'll just put this in the quadratic formula to get our answer. So remember our good fun quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Y'all got that? So -b would just be a +2. B squared minus 4 times a times c all over 2a. Which is 2 plus or minus the square root of 12 over 4. And your answers will have the fully simplified version of this. So I want to make sure we all remember and know how to simplify in the quadratic formula form. Is there a perfect square that lives in 12? 4, right? This is the same as root 4. I meant to write a 4. Another color. There we go. So this is root 4 times root 3. Okay. So we have 2 plus or minus, the square root of 4 is 2 over 4. So when you see these answers, they will have simplified the square roots. And also, you look in these 3 terms here, these 3 numbers. I think of it as like my simplifying triangle for the quadratic formula. Is there something that's in common with 2, 2, and 4? A 2. We divided 2 out of all 3 of those things. So 1 plus or minus root 3 over 2. When you simplify, you leave everything the same in the square root. You're just looking at these 3 numbers. So we divided all of those by 2. So our first root we found was 1/2. Our second root was 1 plus root 3 over 2. Our third root was 1 minus root 3 over 2. Okay. And with these, with the quadratic formula, I'm not making you write them in factored form, because you already had to find all that mess. So 1 plus or minus root 3 over 2. It's huge. So those are my 3 roots. Jason, is he learning pre-cal? Or are you teaching him how to sit? That's funny. Yeah, dog up on the
Both of my dogs want to go outside, so they've been jumping up on my bed throughout the whole class.
So tell him it's a pretty day. You gotta stay inside.
Can I go let them out real quick?
Yeah, that's fine.
Okay, thank you.
All right, y'all guys, go ahead and get working. The first couple problems in this are really, really quick. The second part, you're just putting in the calculator and checking them. And I only gave you 4 that you had to do the synthetic division on. Those were the last 4. So the rest of them are possible roots, how many roots are there, or using the calculator to do that. Marlon, did you see the app that I wrote down for the calculator? It's called Calculate 84. So if you search for that in the App Store, you can get it on your phone, and it's just like a regular school calculator. And my office hour tomorrow is going to be from 10 to 11. So I'll just have a Google Meet up with a link in Google Classroom for that, for you guys to just log on to that. If that time doesn't work for you, then you can email me if you have any other questions for this. Okay. Did I tell you that already? I don't remember.
Can you go back down to that last one that we did? I need to write down that last part of that example.
What took you so long?
I don't know, Miss Roselle.
There you go.
Okay, thank you.
You're welcome. Now I'll stop my recording.